90 million Americans were inside one severe weather corridor yesterday. 25 million more were inside a record-tier heat dome with 850 millibar temperatures, measured at 2 to 3 standard deviations above the Climate Forecast System Reanalysis baseline. Both were produced by the same upper-level pattern. Today, the cold front that ends the event arrives across the mid-Atlantic and New England, bringing damaging downburst winds this afternoon and a 25 to 30 degree temperature crash by Friday. Here's the timeline, the physics, and what to watch for after the front passes. Yesterday, May 19th, 2026, the National Weather Service was carrying 366 active alerts simultaneously across the United States. That single number is the cleanest summary of what the atmosphere did on one calendar day in the middle of May. 366. 59 of them were flood warnings. 32 were gale warnings. 12 were freeze warnings. 9 were heat advisories. The Storm Prediction Center carried a slight risk severe weather outlook on a corridor that ran from west central Texas through the Ohio Valley and the lower Great Lakes and into northern New York and Vermont. Inside that corridor were approximately 90 million Americans. At the same time, 4 separate National Weather Service forecast offices along the Interstate 95 corridor. Mount Holly, New Jersey, covering Philadelphia. Baltimore, Washington, covering the District of Columbia. The New York City office at Upton on Long Island, and Boston, covering southern New England, were all issuing record-tier early-season heat language. The combined heat advisory belt stretched from central Virginia through the entire urban Northeast. Inside it, by population, sat another 25 to 30 million people, with substantial overlap into the severe weather corridor to the west. The total population caught inside one or both operational events on a single calendar day approached half of the United States. The number 90 million did not come from a single source. It came from operational convergence across multiple forecast offices, the Storm Prediction Center, and the broadcast meteorology community, as everyone working the maps yesterday reached the same conclusion at roughly the same time. The slight risk corridor covered approximately 1.4 million square kilometers. Inside it sat Dallas-Fort Worth with a metropolitan population of about 7.6 million. The Ohio Valley urban centers, Cincinnati, Indianapolis, Columbus, and Cleveland, added another 12 million. The lower Great Lakes industrial corridor through Detroit, Toledo, and Buffalo added another 8 million. And on the northeastern end, every city from upstate New York into northern New England added several million more. The primary threat across the eastern leg of the corridor was damaging wind. The operational forecast called for gusts in the 45 to 65 mile per hour range in the typical cell, with isolated gusts of 70 to 75 in the most intense cells. That is the wind speed at which loose tree limbs come down, power lines fail, and the regional electric utilities start reporting scattered outages by the thousands. The west central Texas leg of the corridor was a different threat. Down there, the synoptic environment supported discrete supercell storms developing in the mid to late afternoon along a sagging cold front. Mixed layer convective available potential energy was forecast at 1,500 to 2,000 joules per kilogram. Effective bulk shear ran in the 35 to 45 knot range. Those numbers are the textbook signature of supercell hail. The hail size forecast was baseball, 2 3/4 inches in diameter, give or take. The operational warning emphasis fell on the western side of the Dallas-Fort Worth Metroplex, Central Texas near Abilene, and the Interstate 35 corridor south of Dallas-Fort Worth toward Waco. Baseball-sized hail is the size of hail that destroys vehicles, breaks residential and commercial windows in numbers, and routinely injures anyone caught outside without shelter. The eastern half of the wave produced a different kind of damage profile. The Boston office, in the area forecast discussion issued yesterday afternoon, placed 850 millibar temperatures over southern New England in the range of plus 18 to plus 20 degrees Celsius. That number is the temperature approximately 1 mile above the surface, and it is the variable operational forecasters watch when they want to know how hot a column of air can get when you mix it down to the ground. The Boston office described the departure as 2 to 3 standard deviations above climatology in the Climate Forecast System Reanalysis baseline, running from 1979 to the present. A 3 standard deviation event at any given calendar position occurs in approximately 0.3% of cases. For the May 19th calendar position, where the empirical baseline runs 47 years back, a 3 standard deviation event would be expected to occur about once every 300 years at any single station. What the Boston office described was not a single station. It was a coordinated 2 to 3 sigma signal across multiple Northeast cities at the same time. The Baltimore-Washington office described another day of challenging record high temperatures and placed 850 millibar temperatures over the mid-Atlantic at plus 19 to plus 23 Celsius. Even hotter than what Boston was seeing. The forecast high range for the immediate I-95 metros and the Central Virginia Piedmont ran between 96 and 98 degrees Fahrenheit. The Mount Holly office described the day as record-setting early season heat. The New York City office issued its first heat advisory of 2026 for Northeast New Jersey and the New York City Metro, valid from 11 in the morning until 8 the following evening, and called it the first high heat index event of the year for that population. The first heat advisory of the year for the largest metropolitan area in the United States, issued on May 19th, is a calendar anomaly all by itself. Historically, the New York City Metro's first heat advisory of the season arrives in mid to late June. The advisory falling more than a month early matters because of the public health variable that operational forecasters call the acclimation gap. A human body that has been living in mid-70s, weather for the past 3 weeks, cannot cool itself as efficiently in mid-90s heat as a body that has been acclimated to summer temperatures across a full month. The sweat rate response is lower. The vasodilation response is slower. The threshold at which the body crosses from uncomfortably warm into genuine heat stress is lower. The result is that 96 degrees in mid-May is, per degree, medically more dangerous than 96 degrees in mid-August. Yesterday's heat fell on a population that was not ready for it. Today, the heat continues for the second day, and the body that did not adequately cope yesterday goes into today already partially depleted. Here is the part of the story that the broadcast meteorology format rarely has room for. The severe weather corridor and the heat dome were not two separate weather stories that happened to share a calendar day. They were the two operational faces of one upper-level pattern. A pronounced trough sat over the western United States. A strong ridge sat anchored just off the southeast coast and the western Atlantic. The two features formed a single, high-amplitude Rossby-wave configuration, and that configuration produced both outcomes through the same physics. On the western side, under the trough, the atmosphere rose. The rising motion produced cooling, condensation, clouds, and precipitation. The cold front sagging across the southern plains was the boundary between the cool air the trough was transporting southward and the warm air the ridge was holding in place to the east. The severe weather along that front was the convective expression of the energy gradient between the two air masses. On the eastern side, under the ridge, the atmosphere sank. The sinking motion produced warming, drying, and the suppression of vertical mixing. The heat dome was what happens when an entire continent's worth of air gets compressed downward through the column and warmed dry adiabatically as it descends. One wave. Two physical mechanisms operating on opposite sides of it, both expressed simultaneously across half a continent. The literature on this configuration has been building since the late 2010s. Kornhuber and colleagues published a paper in Nature Climate Change in 2020, identifying a class of high-amplitude wave called wave number 5 to 7, quasi-resonant amplification. The paper found that during these resonant amplification events, the probability of concurrent heat extremes across multiple major breadbasket regions of the Northern Hemisphere is enhanced by up to 20 times relative to non-resonant periods. The 2023 follow-up paper in Nature Communications found that current generation climate models underestimate the observational frequency of these synchronized concurrent extremes, meaning the real atmosphere is producing more of these compressed multi-hazard events than the models predict. Yesterday's configuration was operationally consistent with that framework. Today, May 20th, is the operational pivot. The cold front that was sagging across the southern plains yesterday is now driving northeastward through the mid-Atlantic and southern New England. The Baltimore-Washington office, in yesterday's discussion, called the post-frontal cooling a 25 to 30 degree nosedive late this week. The Boston office described the period as cooler and unsettled into the holiday weekend with low forecast confidence. The Mount Holly office described much cooler temperatures by the end of the week behind the front. All of those offices, reading the same model guidance, arrived at the same conclusion. The atmosphere is flipping. The Storm Prediction Center has a marginal to slight risk severe weather threat across the Cumberland Plateau through the mid-Atlantic and into southern New England this afternoon and evening as the front passes. Damaging downburst winds are the primary threat. Isolated marginally severe hail is also possible. The synoptic environment ahead of the front includes 1,000 to 2,000 joules per kilogram of mixed-layer convective available potential energy and a 1 to 1.5 kilometer well-mixed boundary layer. Those numbers support locally damaging wind gusts as the front pushes through during the afternoon and into the evening. Behind the front, the air mass that arrives is a colder, drier mass originating over central and eastern Canada. A person who walks outside in Philadelphia at 3 this afternoon will feel air that is somewhere in the high 80s or low 90s as the front approaches. The same person who walks outside in Philadelphia at 3 Friday afternoon will feel air that is somewhere in the high 60s. That is a 30-degree change in the variable the human body uses to calibrate every behavioral decision: clothing, fluid intake, outdoor activity, air conditioning use, within 48 hours across one weather system. A 25 to 30 degree drop is in the upper tail of frontal passage magnitudes for the May calendar window. A normal late May cold front in the mid-Atlantic produces a 5 to 10 degree drop and a noticeable but not extreme weather change. The cold front is the pivot for a different reason than the obvious one. Yes, it ends the heat. Yes, it produces a second wave of severe weather along its boundary. But what makes it the structural pivot of this event is what happens to the synoptic environment after the front passes. The wave that produced yesterday's compressed multi-hazard pulse exits the configuration when the front passes through. The trough over the western United States moves on. The ridge over the Atlantic flattens. The configuration that organized itself across the past week into yesterday's maximum is dismantled within 48 hours. The regional electric utilities that ran their grids hard yesterday and the day before are going to see demand drop sharply by Thursday and Friday. The peaking plants that came online to handle the air conditioning load will go back into reserve. The wholesale electricity prices that spiked across the Eastern Interconnect will fall back toward normal. The emergency rooms that absorbed heat-related cases over the past 48 hours will see those admissions taper off. The cooling centers that opened across the I-95 metros will scale back operations. The water utilities, the public health systems, and the infrastructure operators that absorbed 2 days of peak summer demand in mid-May will return to normal operations within 48 hours. and then the atmosphere goes quiet. The operational forecast community has identified the period between today's cold front passage and approximately May 25th through May 28th as a sustained window of synoptic-scale silence. Not the absence of weather, the absence of organized weather. There will still be scattered showers and thunderstorms. The temperatures will rise and fall with the diurnal cycle. Weak shortwaves will move through and produce localized convection, but there will be no multi-hazard pulse like yesterday, no severe weather outbreak, no continental scale frontal passage that drops temperatures by 30 degrees. The atmosphere is going to breathe out for the better part of a week. That quiet has a physical explanation. A high amplitude wave configuration that persists for days draws energy from the surrounding flow. It draws from the equator to pole temperature gradient and from the kinetic energy of the jet stream. When the wave persists for days, it depletes the local energy reservoir. When the wave finally exits, the atmosphere it leaves behind is depleted of the synoptic scale energy required for another high amplitude wave to form quickly in the same region. The Hahn 2021 paper in Water Resources Research on low phase speed Rossby packets and persistent regional drought touches on this. The post-event environment is structurally quiet. Several days are required for the surrounding flow to reorganize and a new energy gradient to build up before the next high amplitude wave can form. The next legitimate shot at significant organized severe weather is identified by the operational forecast community as approximately May 25th through May 28th. The timing matters because it is the Memorial Day weekend window, when millions of Americans travel, attend outdoor events, and otherwise have unusually high exposure to weather disruption. The Coca-Cola 600 at Charlotte Motor Speedway and the Indianapolis 500 both fall inside that window. So does the agricultural sector's critical late planting and early vegetative growth stage across the central United States. What the next wave arrives as, no one knows yet. The model guidance at this range is too uncertain for confident statements about specific severe weather threats. But the operational expectation is that another high amplitude configuration is going to organize itself by the end of next week. And when it arrives, it lands on an atmosphere that has had time to rebuild its energy reservoir. The silence and the next event are part of the same story. Yesterday's heat dome did not happen on a normal piece of ground. It happened on a piece of ground that is, by the formal measurement of the National Centers for Environmental Information, in the worst spring drought condition the modern instrumental record has ever recorded. The Palmer Drought Severity Index for March 2026 was minus 7.85. The April value was minus 7.56. Those are the most negative monthly values the index has produced since the Dust Bowl years of the 1930s. Approximately 44% of the lower 48 is in D2 severe drought or worse. The Southeast climate region had 99% of its area in drought at the late April reading. That is the ground the heat dome sat on yesterday. The Morales 2019 paper in the Proceedings of the National Academy of Sciences identifies a soil moisture atmosphere coupling that increases the likelihood of an extreme heat event by approximately 30% when underlying soil moisture is in the lower 10th percentile of the historical distribution. The mechanism is straightforward. Evapotranspiration cools the air. Dry soil cannot evapotranspire. When the soil is dry and a heat event begins, the cooling that would normally moderate the heat is absent. The heat builds. The further heat dries the soil further. The feedback amplifies. Yesterday's heat across the I-95 corridor was, in part, a downstream consequence of a drought signature that has been building for months. The Williams 2022 paper in Nature Climate Change places the recent southwestern megadrought in a 1,200-year context using a tree ring network extending to the year 800 Common Era. The paper finds that the 2000 to 2021 period was the driest 22-year stretch in the southwestern United States in at least 12 centuries, with 42% of the soil moisture deficit attributable to anthropogenic forcing. The drought is amplified by climate forcing. The heat dome was amplified by the drought. The chain runs from the long-term climate trajectory through the soil moisture deficit into yesterday's surface temperature anomaly. If yesterday's atmospheric configuration is what the eastern United States can produce, with the oceanic Niño index still officially neutral, the question is what the same configuration is capable of producing 6 months from now under a more energetic ENSO backdrop. The current index reading for the February-March-April 2026 season is plus 0.11. The recent history runs negative 0.51 in the September-October November 2025 season, then negative 0.55, then negative 0.54, then negative 0.37, then negative 0.15, then plus 0.11. The trajectory is warming. The Climate Prediction Center has issued an El Niño watch as of May 2026. The operational forecast probability of El Niño development by the May-June-July window is approximately 61%. The probability of a strong or stronger event by the December-January-February 2026 to 2027 peak is approximately 1 in 3. The point is not that another event of yesterday's magnitude is imminent. The point is that yesterday's event was the operational maximum the atmosphere can produce at the May 19th, 2026 position under a neutral ENSO state. As the ENSO state moves from neutral toward El Niño watch and potentially toward a strong tier event by the end of the calendar year, the distribution from which the atmosphere draws its operational events shifts. The mean of that distribution moves. The upper tail extends. The literature has not yet produced a confident decadal projection for how the frequency of compressed multi-hazard events like yesterday's will change as the ENSO trajectory plays out. The Kornhuber papers identify a frequency increase that the models already underestimate. The Williams megadrought attribution identifies a baseline shift in soil moisture conditions. The pending ENSO transition adds a forcing increase. The combination points in one direction, but the magnitude is uncertain. What is certain is that yesterday was a calibration point. The atmosphere demonstrated on a single calendar day in mid-May what it is capable of producing under current conditions. The events that follow over the coming months, as the ENSO transition advances and the climate forcing continues to accumulate, will be drawn from a distribution that yesterday has shown is shifted upward. 3 things are worth watching over the next several days. The first is today's cold front passage and the temperature crash that follows. Mid-Atlantic and southern New England residents will see the front move through this afternoon and evening, with locally damaging wind gusts the primary severe threat. Behind the front, expect a 25 to 30 degree drop in afternoon highs by Friday. The grid stress, the public health stress, and the infrastructure stress that accumulated over the past 48 hours will reset. Cooler and unsettled weather is forecast into the Memorial Day weekend. The second is the persistence of the central United States flood signature. Houston's forecast office identified day 1 through 7 quantitative precipitation forecast values of 5 to 7 inches becoming likely for southeast Texas, with a flood watch issuance for Friday explicitly named as a possibility. The Indiana White River System and the Missouri Grand River System are carrying flood warnings extending into next week. The ground in the central United States is saturated. Additional rain landing on saturated ground produces flood stage rises faster than a typical hydrograph. Watch the watershed gauges in your area if you are downstream of either system. The third is the May 25th through 28th window. The operational forecast community has identified that range as the next significant organized severe weather window. The synoptic environment between now and then is forecast to remain not very favorable for organized severe weather. When the next wave organizes itself, it will arrive on the leading edge of Memorial Day weekend, with the population travel patterns and outdoor exposure profile that the holiday weekend produces. Stay attentive to the storm prediction. Center's Day 3 and Day 6 convective outlooks as the week advances. We will track this as the pattern resets. The atmosphere yesterday produced one of the largest compressed multi-hazard events of the spring. The pattern that produced it is exhausting itself in real time. What comes back to replace it, and what the trajectory implies for the rest of the year, is what we will be covering as the data comes in.